Now we have adding vectors using unit vectors. Right. So suppose vector r is the sum of vector a plus vector b, and these two vectors, the vector a and vector b, are expressed in terms of their components with unit vectors. Alright, so if you can still remember adding vectors using components, we will add all x component and then we'll add all y components. Then we have the y and x and y component of a sum of vectors. So the sum of vector r, which is vector a plus vector b, will be expressed in terms of r of x. R of x is the sum of the all x components of the given vectors, which is vector a and vector b. So that is r of x is a of x plus b of x, and for r of y, which is the y component of the resultant vectors or the sum vectors, will be a of y plus b of y. So since it is expressed in terms of unit vector components with unit vectors, then vector r as the sum of vector a plus vector b will be r of x I hat plus r of y j hat. So this is for two-dimensional vectors. And so again, r of x is a of x plus b of x, and r of y is a of y plus b of y. So the magnitude of r is the square root of r of squared plus r of y squared. So I discussed this already, how to add vectors using their components. And then the direction from positive x-axis will be the inverse tangent of r of y over r of x. Now, if that vector is a three-dimensional vector, then and vector r is the sum of vector a and vector b, then again we'll add all x components, then that is the x component of vector r. And then we're going to add all y components, then that is the y component of vector r. And then for the third component, which is the z component, we will add all z components, then we'll have the z component of vector r. And the magnitude of the three-dimensional vector is still square root using Pythagorean theorem. Still square root of r of x squared plus r of y squared plus r of z squared. And the direction theta equals inverse cosine over r of x over the magnitude of r. So this is for the three-dimensional vector. Just for example, these are the two given vectors. We have vector a equals 3i hat minus 2j hat plus 4k hat. 3 is the x component of vector a, negative 2 is the y component of vector a, and 4 is the z component of vector a. And then vector b as a x component of 2, y component of negative 7, and the z component of 5. So we will look for vector a plus vector b, and the sum of these two vectors will be represented by vector r. Alright, so vector r equals vector a plus vector b. That will be equal to a of x plus b of x I hat plus a of y plus b of y j hat, since this is sum. And then so we have plus bx because we have vector a plus vector b. Okay, so plus by j hat plus a of z plus b of z k hat. Alright, so what is a of x? 3. This is the x component, 3. So you have 3 plus what's the x component of b? 2. So 2 I hat plus what is a of y? Negative 2. Negative 2 plus by negative 7. So plus negative 7 j hat plus what is az, the z component of vector a, that is 4. Then that is 4 plus bz, the z component of vector b, is 5 times k hat. It's vector r. So vector r equals what is 3 plus 2? Simple. 5 I hat. What is negative 2 plus negative 7? That's negative 9. So that's plus negative. Then you have minus 9 j hat. And then what is 4 plus 5? That is 9. Positive 9. So you have plus 9 k hat. Alright. So this is the sum of vector A and vector B. Okay, suppose we have the same given vectors, but this time we look for vector A minus vector B. Then that's vector R. Okay, same given vectors, but this time we look for vector A minus vector B, which is equal to vector R. Right, so vector R is equal to A of x. So this is A minus vector A minus vector B. Then this is AX minus BX times I hat plus for y component, that is A of y minus, since this is minus vector B, then that is minus B of y k hat plus for z component, that is A of z minus B of z, I'm sorry, this is j hat. This is along y-axis, so this is j hat. So for z, that's A of z minus B of z k hat. Alright, so vector R equals, what's A of x, that is 3 minus B of x, which is 2 I hat, plus what is A of y, it's negative 2. This is negative 2 minus B of y is negative 7, so that's minus negative 7 j hat, and then plus A of z is 4 minus B of z is 5, and it's minus 5 k hat. So vector R equals, what's 3 minus 2? That's 1. So I don't need to put 1. It's understood that there is 1 beside I, left side of I. 3 minus 2 is 1, so that's I hat. Plus negative 2 minus negative 7, that is 5 j hat. Right. Then plus, what's 4 minus 5? That's negative 1. So that's plus minus 1 or minus k hat. So this is vector A minus vector B in terms of components and unit vectors. So let us have another example. These are the two given vectors. Vector A equals 2j hat minus 3k hat. Vector B is 4i hat plus 2j hat minus 6k hat. By looking at vector A, it has no I hat, so it means the x component is 0. Okay, it only has, this vector has only have y component and z component. It has no x component. And we look for vector A minus vector B. And vector A minus vector B is represented by vector R. So we have vector R equals, since this is negative vector, this is vector A minus vector B, then we have AX minus BX I hat, and then plus AY minus BY j hat, plus AZ minus BZ k hat. Alright, so what is A of x? That's 0 minus B of x, which is 4, and this is I hat. And then plus, what's A of y? That is 2 minus B of y, which is 2. j hat plus what's a of z? A of z is negative 3, so this is negative 3 minus b of z is negative 6, so minus negative 6 k hat. So let us solve. What is 0 minus 4? That's negative 4 I hat plus 2 minus 2 is 0 times any unit vector, so 0 times j hat is 0. So plus negative 3 minus negative 6, that's plus, what is negative 3 minus negative 6? That is 3, so plus 3 k hat. So the sum of these two vectors, vector A and the negative of vector B, is negative 4 I hat. It's negative 4 I hat plus 3 k hat. It has no z component. So let us have another example. So this time we'll deal with more than two vectors. Okay, sum of more than two vectors. So these are the three given vectors. Three given vectors. Vector A is 2i hat minus 3k hat. Vector A has no y component. Vector B is 3i hat plus 4j hat minus 2k hat. Vector C is I hat, so it has one unit component, x component of this vector C has x component of 1 unit. So vector C equals I hat minus 2j hat plus 7k hat. And then we will look for vector A minus vector C plus vector B, which is equal to vector R. Alright, so this is three vectors. Then vector R, okay, vector R equals, it's the first vector, negative, what's the first vector? That's vector A, so this is A of x. What's next? Minus C, so that's minus C of x. Next is plus vector B, then that is B of x I hat. Alright, now for the y component of vector R, so that's plus vector A, so that's AY minus vector C, then that is minus CY plus vector B, then that is plus BY j hat. And then plus for the z component of vector R, since this is vector A, then we have AZ minus CZ plus, this is plus vector B, then this is plus BZ k hat. Right? So vector R equals, what's A of x? 2. Right, 2 minus C of x 1 plus B of x. B of x is 3, so plus 3 I hat plus, what is A of y? 0. Vector A has no y component, so this is 0 minus, what is C of y? Negative 2, so that's minus negative 2 plus by. By is 4 times j hat plus A of z. What's A of z? Negative 3, so negative 3 minus C of z. The z component of vector C is 7, so minus 7. Right? And then, oops, there's still plus B of x plus B of z. B of z is negative 2. So double check. A of x is 2 minus C of x is 1 plus B of x 3. Okay. Plus A of y is 0 minus C of y, it's minus negative 2 plus B of y, which is 4. Okay. Plus A of z is negative 3 minus C of z, which is 7, so minus 7, plus B of z is negative 2. Okay. need to put k hat. Alright, so let us solve. So vector r equals, what's 2 minus 1? That's 1 plus 3. It's 4 I hat plus negative 2 plus negative 0 minus negative 2 is 2 plus 4, that's 6 j hat. How about at k hat? Negative 3 minus 7, that's negative 10 plus negative 2, that's negative 12 k hat. Okay. 2 minus 1 is 1 plus 3 is 4. 0 minus negative 2 is positive 2 plus 4 is 6. Negative 3 minus 7 is negative 10 plus negative 2, it's negative 12. So vector A minus vector C plus vector B equals 4i hat plus 6j hat minus 12k hat. So let us have another example, the last example. Two given vectors, we have vector B equals 3i hat minus 2j hat plus 6k hat. And vector C is 2i hat minus 2j hat minus 5k hat. So this time we'll look for 3 times vector B. What is this 3 times vector B? So it means each magnitude of vector B is multiplied by 3. Then minus vector C, okay, equals vector R. So let us solve for, let us solve for vector R. So vector R, we start with 3 times vector B, so that is 3 times Bx. Since minus C, so it's minus Cx. I hat plus for the y component, 3 times, since this is 3 times vector B, then you have 3 times by minus cy k hat, right? And then for z component, so plus 3bz minus cz. No, I'm sorry, this is j hat. So this is j hat and this is k hat, right? So we have vector R equals 3 times, what is b of x? Negative 3 minus c of x, which is 2 I hat plus 3 times b of y. 3 times b of y is negative 2. Okay, minus c of y is negative 2. Oops. Negative 2. J hat plus 3 times bz. 3 times 6. This is the component of vector b is 6 minus, what is c of z? Negative 5. Minus negative 5k. So vector R equals negative 3 times 3, that's 9 minus 2 I hat plus 3 times negative 2 is negative 6. So minus negative 4, negative 2, and that is plus 2. J hat plus 3 times 6 is 18 plus minus and negative, that's 5 k hat. So vector R, okay, vector R is 9 minus 7 is 7, 9 minus 2 I mean, that is 7, so you have 7 I hat plus negative 6 plus 2, that is negative 4, so that's plus negative, so it becomes negative 4 j hat, and then plus 18 plus 5, that's 23 k hat. So 3 times vector b minus vector c equals 7 I hat minus 4j hat plus 23 k hat.